All right. Well, welcome back. My name is Andrew Aronson. This afternoon, we'll be walking you through another CS14 session. This one is going to take you through the voice integration and coexistence with things like a PBX or gateway or the PSTN infrastructure, as well as the changes around mediation server and media bypass and some of the functionality that enables that. If you came to the session this morning, we figured out why the certificate wizard crashed. Those snapshots were from about a week ago, and the Kerberos ticket had timed out. If I had logged off and logged back on, the certificate wizard completed. So I apologize for not catching that. Normally when I re-snapshot the machines in the beginning, I log out and log back on, and in the rush to get everything set up there with the video portion, I missed it. So apologize for that one. So in this session, though, we'll cover the voice architectural changes in CS14, a little bit about the deployment topology and how that's changed substantially from what you see in R1 or R2 today. We'll spend a little bit of time around the signaling and media. We're going to show you some demos of the call quality on codecs for RT audio narrowband versus G711, and how that comes into play when we start talking about stories like media bypass and other pieces like that. There's some new server-side voice functionality that's introduced in CS14 as well. As for that, we'll also do a little demo with Paul Dolly live towards the end of this, where we'll show how the client itself is able to resolve some of those issues in the rapid resumption of service. So if you saw Paul's overview session yesterday, he went over this slide where he talked about what was in R7 or 2007 R1, 2007 R2. For this session, what we're going to focus on is the content on the CS14, really around things like the topology, media bypass, the concepts of analog devices, and what we've done around things like elevator phones or fax machines, for example, common area phones, private lines, and other PBX-style functionality that we've introduced in CS14. So with that, let's take a quick look at what our CS14 topology looks like. The major change, if you're looking at this topology diagram from a 2007 R1 or 2007 R2, is a dramatic reduction in server roles. So it's still possible to deploy CS14 and have dedicated mediation servers and dedicated AV conferencing servers, etc. But by default, we're able to co-locate those services on one of the front-end servers in your pool, whether that's a single standard edition front-end server running all services, or whether that's one of your enterprise edition servers running in an array to provide some level of high availability. In this topology, we have the mediation server broken out from the other servers in the pool because there is a difference in how we route traffic around SIP trunking versus direct SIP. And merging it into that same diagram makes it a little difficult for us to show it. But in the diagram, you can see that we can run mediation server either in the pool or outside of the pool, depending on our usage requirements, basically. No longer a technical requirement or a choice we might make during deployment. The excuse me, sorry about that. The other piece that you'll see that's new on here is the concept of the survivable branch appliance, or gateway, near the bottom. And this is our answer for the remote branch office locations that want the ability to place and make PSTN calls even when the WAN infrastructure is unavailable. And so if you saw the setup and deployment session, you saw us create a central site. A central site would be one that would house or contain a pool infrastructure, so front-end server roles as well as things like mediation server or conferencing MCUs. The mediation, or the gateway or survivable branch appliance is something that you would deploy to a branch office location, and in that scenario, we're able then to normally route calls over the WAN and through the traditional model that we're routing calls. But in the case of a WAN failure, actually take the calls and route them over the PSTN via a traditional circuit that's attached directly to that media gateway or survivable branch appliance. Also on there, we have the concept of analog devices or analog phones. This has stayed the same as well from R2. We were able to attach things like analog phones or fax machines to a gateway, but we had to manage them on the gateway itself. So for CS14, what we're providing is the ability to have management of that survivable branch appliance or gateway, including the endpoint management and things like routing, contained in our core UC pool infrastructure and pushed out to those gateways or to the survivable branch appliance. One final change for CS14 is Microsoft has made a large investment in enabling all of our services or products to be cloud enabled. And so one of the missing pieces in R1 and R2 was the ability to have Exchange hosted in the cloud, providing unified messaging, but an on-premise deployment of OCS R1 or R2. We had to have both the OCS infrastructure and the Exchange infrastructure both be on-premise if you wanted to use Exchange for voicemail. With CS14, we're now enabling you to have a hosted Exchange infrastructure, but retain the CS14 infrastructure on-premise for your voice solution. So the main thing we're talking about is this concept of combining the mediation server role with that front-end server role, and why we're able to do that. There's a couple pieces to that. One of them is when we had mediation servers today in the R1 or R2 role, those were really dedicated to specific routes and gateways. So we associated a gateway with a specific mediation server, and signaling as well as media traffic would flow through that path. And that was possible to do because we could guarantee in the route which mediation server would be used. Therefore, we always knew it was a specific role or a specific server instance that would be associated with that target gateway. As we move the mediation server to the mediation service and have it running on a front-end server inside of a pool, it's random as to which one of those services a user endpoint will connect to. So if a user is using the Office Communicator client and I have 3 servers in the pool, I don't know which one of those mediation services that end user is going to connect to. As a result of that, I don't know necessarily, the old model where I had a single mediation server linked to a single gateway wouldn't be appropriate for that. So with CS14, we now allow this concept of multiple gateways to be associated with the mediation service instance, but we specify that routing and policy information in the configuration in our route configuration. So our routes can be associated with a gateway, but we're able to transverse any one of those mediation services inside of that front-end pool inside of that. All that information is stored inside of your topology document. So as you deploy your topology using Topology Builder, you'll generate this topology document. That information will be published out to SQL and then replicated to a SQL Express instance on each one of these mediation service roles. We do have the gateway FQDN as part of the request URI. That is how the service finds the appropriate gateway to route that call to inside. Another change, and this is really where we're enabling the co-location of roles, is something we call media bypass. When we capture audio using the communicator client, the first thing that happens is we're going to take the analog spoken voice or audio format that the person is speaking and convert that with a codec into something digital. That first conversion is the richest conversion experience that we have. You could think, and if we then take that codec and transcode it into another codec eventually. Let's say that we capture RT audio, we hit the mediation server, it transcodes it to G711 to submit it off to the PSTN. This is like the making a copy of a copy, right? So if you take a photocopier today and you make a copy of a document, and then you make a copy of the copy and a copy of the copy of the copy, you'll never have as rich or as detailed of a copy as that first copy. So anytime we're transcoding or going through a transcoding operation, 2 things occur. 1, we're never really going to be as good as the original. And 2, that transcoding operation is very CPU intensive. So in the past, with R1 and R2, we had to do transcoding on the mediation server because media from the endpoint flow from Office Communicator to the mediation server. That would be over RT audio or Siren, depending on whether you were in a conference or a peer-to-peer call. And then from the mediation server, it would be transcoded again to G711 or G729 to get to your eventual gateway device. Media bypass says, well, let's configure the communicator endpoints to be intelligent enough to understand that that call is going to a PSTN location, for example, or a PBX inside of the organization. And let's have the Office Communicator client, therefore, encode that call originally with G711 and speak directly to that gateway for media. That means that the mediation server or service is not involved in doing a transcoding operation, which means that we have less CPU utilization on the mediation service. Also, it means that there's a single, the first codec that we captured, G711, is going to be the one used throughout the transmission of that call over to the PSTN and off to the eventual endpoint, meaning we have fewer transcodings, meaning we should have some better call quality as well. So a combination of these has allowed us, therefore, to deploy this concept of media bypass and bypass the mediation server for specific use case scenarios. This, as we say, right, this same concept applies for the mediation service role that exists in the SBA or survivable branch appliances as well. So some big benefits. First of all, there's a topology simplification. We no longer have to have a multiple or a number of mediation servers deployed, possibly one per branch office and maybe several in the central office. We can leverage the mediation service as part of the front-end services, which at the end of the day is reducing the number of servers that are required to deploy CS14. There was a study done at VoiceCon by one of the analysts. Paul mentioned this in his session on Tuesday morning. It turns out, as a result of this, CS14 has the lowest total cost of ownership once you consider in number of servers and types of devices to be deployed inside of an organization. And the other piece, right, is this concept of with less transcoding, we'll have both better call quality as well as less latency between our endpoints that are involved inside of that call. So first part, right, this media bypass really works with three types or three key scenarios. All SBAs that will ship by RTM and are qualified for CS14 are required to support media bypass. So anytime you're deploying a survivable branch appliance, we know that endpoints that are in that location will support media bypass for that SBA. The catch is around the IP-PBX. We're working very strongly with the vendor that's located in San Jose, installs a lot of networking infrastructure, to ensure that the telephony aspects that they're producing are as close as possible to what we can get for media bypass. We're also working with all vendors who produce IP-PBXs. The key here is that there's going to be 3 levels of interoperability with an IP-PBX. One level is we'll support the rich media bypass functionality, including things like call transfer. So if I initiate a call transfer from my OC endpoint, signaling will still run through the mediation service path, but the media itself will flow endpoint to endpoint and skip the mediation service. What this means is that that mediation server service or that middle endpoint has to understand things like a SIP referral when I do a consultative transfer, a type of transfer, so it knows to accept it and redirect the call to the other endpoint. Not all IP-PBXs will support this type of advanced media bypass or level 2 type media bypass functionality. And then finally, there's the ones where we just won't recommend media bypass at all, because not only will they not support the type of transfer scenarios, but they also won't support the basic media bypass interoperability. The final scenario for media bypass is something that we call SIP trunking. With SIP trunking, we are no longer extending traditional circuits to your on-premise infrastructure. We are going to route over the internet to your telco provider. This typically involves something called a session border controller, or a type of back-to-back user agent that the telco will either install on your premises or at their end of a private VPN over your internet connection. Today, most session border controllers are configured to only accept information from a small subset of host names and IP addresses. This which would be the normal configuration, right? You would route calls to an IP-PBX or a mediation server in your enterprise that would collect the calls and create a trunk to that session border controller. What we're really saying with media bypass is we want the endpoints to talk directly to the endpoint. Well, if we're doing SIP trunking, the endpoint is that session border controller, and as a result of that, we're in dialogues right now with telco vendors around the world to say, what about this new model where we want your 3,000 or 500 or 70,000 endpoints all to be able to establish SIP sessions and a media path directly to your SPC. It's not likely that most of them will support that configuration going forward, so by launch, for example. So it's very likely that if you're doing SIP trunking, you will still have to run through a route through a mediation server to get eventually to that session border controller. This may sound a little confusing, so we've got 8 quick diagrams that kind of walk you through what this call path looks like for media bypass. So in this, we have a central site. Here we'll call it the main site. And we have a branch site. Central site has a CS14 pool infrastructure. We've actually broken out the mediation server from that pool for the purposes, again, of highlighting to you what the call flow looks like. And we also have a branch site. In that branch site, we have both an IP-PBX and a gateway or survivable branch appliance. So first example, let's take a look at a call from a main site user, CS14, going to the PSTN. In R1 or R2, that call would be CS14 to the mediation server, It would be RT audio wideband or RT audio narrowband, for example. And then the mediation server would transcode that call to G711 and pass it off to the gateway in the central site. With CS14, the client understands from the registration and the logic in the routing path that its endpoint is going to be a gateway to the PSTN and does the transcoding directly as G711, which can then speak directly to the gateway, no additional transcoding required on the gateway, and G711 packets out to the PSTN internet or the PSTN network. Same concept. In this case, we have a client at our branch site, for example, connecting through the IP-PBX to get a connectivity out to the PSTN. Client understands that the next hop is going to be a PSTN G711 type device, so therefore the client will choose G711 as the codec to talk to that IP-PBX, which will route the call to the PSTN. Eventually, our IP-PBX at this branch site has expired. It's out of warranty, right, out of support, and we decide to replace it with one of these inexpensive gateways or survivable branch appliances. With the gateway or SBA, same approach. When we realize that we're going to be routing to the PSTN from the local branch site, we'll speak G711, no transcoding required. Call is completed then and is sent outbound to the PSTN. Now let's look at a call that flows, for example, from the PSTN, or from the central site. The CS14 endpoint will be G711, and the CS14 endpoint in the branch site will be RT audio. And there's a reason we do this, and we'll show you a demo of this after I show you the slides, which explains how the RT audio codec is adaptive for network conditions that either have higher latency or possibly drop packets. And we'll show you the impact of that on voice quality and how that impacts the perception or the quality of experience for users on that call. The summary is we do media bypass inside of a site when we can guarantee that there's high network throughput and low drop packets. So we have a rich network connectivity experience. When we don't have that rich network connectivity experience, which we assume to be on a WAN connection, we will then drop back to RT audio, which has a better tolerance for that type of drop packets and packet loss. So in this case, we're doing SIP trunking. Therefore, the endpoint has to come into the mediation server. But because it's crossing the WAN, we will default to RT audio narrowband for that WAN connectivity and WAN connection. We've also introduced something called CAC, or the ability to apply policies on our connections between locations. This was something that we did not have in 2007 R1 or R2, which means that in R2, if we were deploying R2 and the CS14 endpoint in the branch site made a call, and then a second one in the branch site made a call, and a third, and a fourth, and a fifth, let's say our network capacity was enough for about 5 concurrent calls. Nothing prevented that 6th person from making a call over that connection and therefore impacting all of the 5 calls that were already in progress. So CAC, or call admission control, is a way of reserving or guaranteeing bandwidth between locations so that we can prevent or give a fast, busy dial tone for the person who's trying to make that connection. In this case, we're showing you a survivable branch appliance. We have call admission control configured on this WAN link, so the client initially tries to make the connection over the WAN to the mediation server, but the CAC policy says that the amount of bandwidth used by OC clients at that location has already exceeded the policy, so we're going to reroute that call to the SBA to the PSTN. So user initially places the call, policy denies them the WAN connection option, they'll fall back to the local SBA or potentially the IP-PBX at the location to place that call locally instead. Same concept applies. The media bypass will work inside of the central site as an OC client tries to talk, for example, to a PBX endpoint. As the PBX endpoint becomes IP-PBXs, the only issue preventing us from talking endpoint to endpoint is the ability for that IP-PBX to give us a list of IP addresses of those phones. And today, IP-PBXs won't give out that list. They're really just a media termination point inside the enterprise. So OC client in the main site has a configuration that says when I'm routing to extension 2015, use the gateway, which is the IP-PBX. The IP-PBX will then pass my audio stream of G711 off to that traditional PBX endpoint or a voice over IP PBX endpoint inside of the organization. But again, you see that we're adapting the codec based on the destination choice and the fact that it's a local call. Finally, we have a branch call between a CS14 endpoint and a PBX endpoint. In this case, again, as we're crossing the WAN, we will use RT Audio Narrowband instead of G711 for the demo that I'll show you right now. So let's take a look at what happens between RT Audio in terms of RT Audio wideband and narrowband with a little bit of packet loss. So we have a recording. I'll play the first recording here first.
The ripe taste of cheese improves with age. Act on these orders with great speed.
So that's a CD quality 44.1 kilohertz record or sampling size. Let's listen to that on a perfect network with G711.
The ripe taste of cheese improves with age. Act on these orders with great speed.
So this is a typical telephone call, right? G711 is a codec we'll use for transcoding and decoding for a PSTN link. RT Audio Narrowband, perfect network.
The ripe taste of cheese improves with age. Act on these orders with great speed.
And it sounds a little better, right? We have the adaptive codec that helps ensure some of that. The main difference occurs when we add a little bit of packet loss. G711 and G729 are optimized for reserve bandwidth. So in a traditional PSTN network, I have 64 kilobits per second of bandwidth on each circuit that I have, and so therefore I will not have any drop packets because I've had that bandwidth reserved prior to the media flow initiating. But when we try to route G711 packets over a data network, those go to it. We dump the buckets out, the bucket of packets onto the router. The router then will route those packets. We have everything from drop packets to packets arriving out of sequence, etc. Data is not tuned for the concepts of voice. So let's listen to G711 with a little bit of packet loss.
The ripe taste of cheese improves with age. Act on these orders with great speed.
So we can start to hear some degradation of quality there. 729, same experience.
The ripe taste of cheese improves with age. Act on these orders with great speed.
You're starting to lose some of that quality that you had initially. But RT Audio has the ability to adapt to that concept of lost packets. There's things such as FEC or forward error correction and some adaptiveness that allows us to take lost packets, look at the voice stream that was happening prior and the next packet, and try to guess what happens in the middle and play back that missing packet experience. So as a result,
the ripe taste of cheese improves with age. Act on these orders with great speed.
And so there's marginal 10% packet loss on the network, but you in effect have basically the same call quality even with that packet loss. And that's the reason we will use RT Audio Narrowband when we cross things like a WAN link, or we believe that there may be not a high-speed, locally connected, low-latency network. Let's switch back. All right, and talk about the next functionality. So there's a lot of advanced PBX functionality that exists with your traditional PBX today that wasn't offered in OCS 2007 R1 or R2. And some of these advanced concepts were things such as a private line. It's common for executives or high-level people in an organization to have a listed phone number. That phone number is in the global address list. It might be published in the phone directory. It may be available on the public website, for example. But that public number or that published number probably has a receptionist or executive assistant or some person managing it. So the call is not going directly to the executive. It's going to a person or a team who's responsible for filtering calls before it reaches that person. If that executive wanted someone to have the ability to call them directly, maybe they've met somebody else that they want to have a private conversation with from another organization, maybe it's their family, or they want their wife to be able to call in and say, hey, the kids are sick today, can you come home early, right? There's this concept of a private line. And so a private line is a second phone number that exists on the person's Active Directory user object. But when any calls are routed to that private line, we will skip all of the functionality that routes the traditional calls through that person's receptionist or admin assistant. So therefore, things like delegation, call forwarding, do not disturb, all these types of options that might filter a call from reaching me will be voided when someone dials my private line. I will see a different toast. I will hear a different alarm or distinctive ring when that call comes in. And as a result, I'll know that call is coming into my private line. As a result, I can take that call or choose to deny it based on normal ringing or normal call answering rules and logic. Paul also mentioned, we'll give you the quick background of malicious call trace. Malicious call trace is the ability for users to report an inbound call as coming inappropriately, and we want to do some due diligence around this. The main piece here is that this can be done either from Communicator or one of the Office Communicator phone editions. After the call's ended, you have the choice of marking the call as malicious, and we will then send all the aspects of that call. Which gateway did it come in on? What was the DID number of that call when it reached the gateway? What was the codec used as it was being transcoded? What was the endpoint? What was the call quality, right? All that information will be stored as a call detail record in our monitoring server, and it will now be flagged as a malicious call that an admin can go back, take a look at, and follow up by either reporting to law enforcement or internal security, for example, for that incoming malicious call. The next piece is around this concept of analog device management. So we've had some analog device management on gateways. You could plug in, like we said, analog phones or fax machines or elevator phones into your existing gateway on 2007 R1 or R2. But you had to manage those devices on the gateway itself. We had no way to centralize routing and topology information and push that to these gateways or survivable branch appliances. The difference now is now we can have this FXS port or inside port to allow these analog devices to connect, but the numbers and the routing associated with that are all part of our centralized dial plans and routing infrastructure. So when we need to make changes, we don't need to go log in to all the web portals on the gateways inside of the organization or use a special tool to manage those gateways. We use our normal CS14 infrastructure to go ahead and manage all of our analog devices that are inside of the organization as well. Another key piece to this is that we're going to make sure or ensure that all the call detail records are, for all these analog calls are reported from that gateway or SBA back to our call detail record server as well. So if we need to do things like auditing or logging of any of that call information, that's already accommodated. It's going to be in the same monitoring server infrastructure as all the other calls in the organization, and it's easy for us then to track and report usage on the analog devices inside of the organization. Another change to bring CS14 up to par with the traditional PBX or telephony solution is the concept of caller ID presentation. It's common in a call center scenario or sometime in a legal or security group in an environment that they don't want the person's extension exposed to the outside world when that person makes a call. And we didn't have a way really to do this on the individual user basis prior, but now you have some very granular controls around what you want to display. Do you want to display nothing at all? Do you want to display a generic corporate extension for the outbound calls? Do you want to display the person's specific phone number for outbound calls? Right? So here we have Alice dialing out to a PSTN number. One option is she gets the 1-425-555-1000. Another option is, the same scenario, she dials internally, we'll preserve that and show the 555-2302 or the full extension inside. So we give you the choice, not just for outbound calls, but also for making internal calls, at what level you want your caller ID to be presented as to the B party who's going to be receiving that call. We've also addressed the issue of simultaneously ring. So if I have my Office Communicator client up and I configure it to simultaneously ring my cell phone, in the past, that call to my cell phone would show up as, we publish, for example, our common Microsoft Access number there, so I don't see who's calling me. I just see the generic 1-425-555-1000 on my cell phone. With the override for this for internal calls, if somebody now calls me internally, it will pass their extension off to my simultaneous ring device rather than being presented with the generic outbound call that would be coming from a mediation server or from our CS14 infrastructure inside. So this allows me, whether I'm at my OC client, I'll see caller ID. Also, if I have simultaneous ring on my cell phone or on my home phone, I will see caller ID exposed there as well. We do have the ability with a hotfix to do some of this functionality with 2007 R2. So if you've got OCS 2007 R2 and deploy the hotfix, you have a limited subset of what you can do here with the caller ID presentation. So a quick couple screenshots we show you in the CS14 control panel. Here we're checking suppress caller ID and specify an alternate. We're specifying the alternate here as 425-882-8080, which is what will show up if someone from Microsoft in Redmond gives you a call. Additional enhancements, right? All the formatting and routing is done centrally. So in this case, it's common for organizations to want to route calls that are going to overseas destinations over their WAN network instead of over the PSTN to avoid toll charges. So here we have a scenario where if Alice is in Redmond and dials +4422123456 or a UK number, we will normalize that number based on call logic to the 011 or signal that it's an international call when we hand that off to a gateway in Redmond. But if we decide to route that call to a gateway in London, we will normalize that call to just to 02-212-34567, which is a direct dial access number in London. So now the call, regardless of how Alice dials it originally, is going to be formatted appropriately through normalization rules, depending on where the call exits your organization. So we can tune the call routing to ensure that when the call's exiting CS14, that the gateway doesn't need to have any normalization rules. We will hand off just the numbers or the digits that that gateway needs to dial to simplify your overall dial plan and call routing. And here we show the screenshot of adding in the translation code. Another aspect, we introduced the response group service in 2007 R2, but we've added a lot of functionality now around the response group application. So a response group is if you think about it, it's a way for me to call into a response group and get prompted for scenarios, right? So press 1 for this, press 2 for that, press 3. Maybe I press 3, and then I get prompted again, press 1 for this, press 2 for this, press 3 for that. With 2007 R2, your ability to deploy a response group was somewhat constrained. You had to choose either 2 options or 4 options, and the 4 options could have 2 options or 4 options. And you were limited in how you carved out the tree or managed this type of response group scenario. With CS14, we've removed those restrictions. It's now simpler. If you want to have 8 prompts on the first level, 2 prompts for when someone presses 1, and 5 prompts when someone presses 3, we give you more flexibility in that regard to customize what your response group application will look like. It's also common when you have a response group that you have a large number of DID numbers. Let's say you have a block of 500 numbers assigned to people in the organization. And people leave and change roles over time, so some of those digits may go unused. So a person dials in on one of these extensions that someone had called them back before. Today, if they call back on those digits with R2, they'll get a fast busy signal. With CS14, for your unused numbers in your DID pool, you can go ahead and have a message that plays. It says this message, this number is currently not in service, but I'm going to transfer you over to the main office extension or this person's replacement, for example, or something like that. So we have a way to manage calls inbound to the unlistened for, the numbers or extensions that aren't in use in the organization. We also support adding WMA audio files, so if people want to record their own either custom greetings or custom music, it's easy to add that for the music on hold and the type of response group prompts that will be used inside of that organization. And we have some options around agent anonymization. So today, if you contact someone through the response group service and you're using the OC client, let's say you're federated or you're an internal user, you'll see the agent SIP URI exposed. So you'll know who the actual person, the SIP URI of the person who ended up taking the call after you've worked through the prompts. Typically, in help desk scenarios or call center scenarios, they like to hide or mask those individual SIP URIs or contact information so that people will call back in through the response group and not try to contact the person directly. With CS14, you now have the concept of hiding that so you can protect the SIP URI for people who are handling or managing those response group queues. Another common scenario is call park. So call park is the ability for the receptionist to take the call, say, hold on please, put the call on hold, announce over the intercom, Andrew, you have a call holding on 615. I pick up any phone in the organization, dial 615. I'll be connected to the person who called that main reception number. This is probably one of the most common scenarios that we did not have in R2 and prior that's now available in CS14. Person who calls in and gets call park will get music on hold. It's a traditional call park type experience. At a certain point, after a certain point in time, we'll time out the call, bring it back to the receptionist, for example. She'll have the option to either put you back on hold or back on call park or try to get you to call back later or handle your call a different way. The final piece is that this concept of voice policy is something that we can apply individually or globally inside of the organization. So all the functionality that we're showing you, whether it's things that existed in 2007 R2 or new functionality that's coming in CS14, is all there via the Communication Server Management Console, so it's very easy for you to add and remove specific features for individual users. For example, I may not have the ability to set up a team call or to have delegation on my CS14 user object. The common scenario for this is things like the common area phones. It's typical that you don't want people using a common area phone for PSTN rerouting or a bandwidth policy override, for example, right? Bandwidth policy override is a scenario where we've deployed CAC, or the call admission control, for a link, and so now the executive in our branch office site wants to make a call. CAC may block that person because the 5 calls or the bandwidth has already been exceeded, but we can specify specific users at that location to override the bandwidth policy controls so that they're always able to place a call regardless of what's happening with CAC. So let's do a demo here with Mr. Paul. While Paul's getting set up, first we'll show you a little bit of information around why we recommend or talk about OCS certified USB handsets. So let's switch over to our demo device. And we're going to do a live call back again. We're on wireless, yep. Live call back against Redmond. Let's do our call quality test. So first thing we'll do is we have this concept, check call quality, which allows users to test or validate their call quality and see what it sounds like. Oh. And let me do that again, but plug the sound into the appropriate location. So we'll do that one more time.
To check your call quality, report a short message to the tone, then wait to hear how you sound.
We're going to test our call quality. It looks like we're having some link issues. If you notice here, you can see that
Here is what I heard.
We're going to test our call quality. It looks like we're having some link issues.
If you like what you heard, then you're all set. If not, check your audio device settings and try again. Goodbye.
Can that come up? There we go. All right, we'll do that one more time so you can see it. You'll notice that the latency here in New Zealand back to Redmond is significant. So her call, right, we had some drop packets, and they were probably looking at 200 to 250 milliseconds
To
for
check your
latency.
call quality, record a short message after the tone, then wait to hear how you sound.
That bandwidth area is what we want you to see. So here's a test of our call quality. I just want to record something, and we'll listen to you play that back to me in a moment.
Here is what I heard.
Area is what we want you to see. So here's a test of our call quality. I just want to record something, and we'll listen to you play that.
If you like what you heard, then you're all set.
We must
If
have had.
not, check your audio device settings and try.
So we had a slightly better connection that time. It might be because I used the wireless network and it came up. But let's take a look at that same type of experience when I'm using a poorly written USB device. So a poorly written USB device is basically going to cause us, or will grab processor utilization, and it won't release it when something else requests an interrupt or asks for some processor time, right? And we see this is pretty common with a lot of or devices that plug in via USB and don't really have a properly written USB driver. What we have here is this little tool called Glitch. So Glitch is going to simulate for us a process that hogs CPU time and doesn't necessarily give it up when it's supposed to. To show you what that's like, we're also going to bring up Task Manager. And we can see that our CPU utilization is running pretty low right now. We're down in the 3 to 4% range. But let's use Glitch, which is, it's got a great interface, doesn't it? We're going to start the stress. All we have is here, we can increase the glitch duration and we can decrease time between the glitch. So let's start increasing the glitch duration a little bit. I'll do that maybe 5, 6 times. And you can see the mouse is starting to get a little jerky. You can see my processor utilization is increasing. I have to be careful with this tool because if I increase it too much, it crashes my machine, right? Eventually, I'll end up with a blue screen. So it's a bit of an art to make a nearly unstable machine or simulate a poorly written driver. But we're going to increase a little more. We'll decrease the time between. We're in the 50%. Usually, you have to get to about, on this machine, it's a quad-core processor, so it takes a bit of input from glitch before we start to hear a difference in the call quality. Let's increase glitch duration some more. Decrease the time. 51, 60, 70. Do a couple more. And we can see it continuing to climb. Now we're in the 65 to 70 range. Increase the duration a couple more times. Now we're really starting to get some activity going. Let's give this call quality again. We might need to go up a little more, but I don't want to get too far there. So we'll do a check call quality.
To check your call quality, record a short message after the tone, then wait to hear how you sound.
Here's that same message I recorded calling from New Zealand, but with some poor information coming from my device, right?
Good.
Here's recorded, but or
If you like what you heard, then you're all set.
I didn't like what I heard at all. But the user tab, right, now we see that we're exposing that to the user. That first they get a little link, your device is causing poor audio quality. So we're going to report in the OC client that it's not the bandwidth, it's not the CS14 infrastructure, right? What we have here is actually a device problem that's causing us the ability to have a clear audio call. What you also may have noticed is her voice came through crystal clear, right? It was my voice that was actually having issues with. So when I'm encoding, it's very important that I'm able to grab CPU time immediately when I need it, or I'll have that sort of rough staccato type recording. When I'm decoding, I need a little bit of CPU time. The decoding process isn't the same. So what this means is that it's very common for users to have a device causing poor quality, but they don't know. The call they're on sounds great, but for all other participants in the call, their voice is coming through in this staccato, choppy, drop packets, lots of jitter type experience. So that everybody else in the call says, oh, this CS14 conference call isn't working out that well. So what we tried to do is highlight for you some of that in the client itself. Let's go and close down glitch before that causes any issues on my machine. And and we have a direct access issue that keeps causing that to pop up. But let's do this some more testing here. This time we're actually going to call Paul. Let me see if is he still in the room or did he go outside? I see, there he is. All right, he's waving up there. So we're going to call Paul Dolly. But Paul and I are both on wireless, so we should have a pretty clear call between us. It's going to be up to the wireless infrastructure in the room, but let's see how that sounds when Paul and I have a communicator call.
Hey, Andrew.
Hey, Paul, how are you doing?
Pretty good, thanks.
Sounds like you got a headset on with a microphone kind of close to your mouth there. I can hear you breathing a little bit. But you're coming through pretty clear. Can you hear me clear, Paul? Hey, Paul, are you there?
Move my beam away for you.
Oh, all right. And hey, look, the wireless network in this room isn't that good, right? We're actually already getting the signal for poor networking conditions. And
Yeah, you're coming through pretty.
it's causing audio quality issues. I can see it's being exposed in the UI. What I wanted to do was have a clear call with Paul. We were hoping that on the same concentrator, right, or same access point, we'd be relatively clear. But to show you the difference or impact that a little bit of latency has, we have, as well as drop packets. So we're dropping some packets obviously here because we can see the red bar there. But we also have a tool called Newt, which basically allows you to go ahead and create things like latency and drop packets. So I'm going to create my connections as required. Apply. Close. So now I have my connections here. And inside of my link, I can then, if you saw me, I'll just bring it up again to show you. I was going to show you the concept here. My link is set for all adapters, so this is going to include my wireless adapter as well, which is where the audio from Paul and I is going over. But what I want to do is introduce some errors, right? So I can do things like periodic loss, random loss, burst loss, some Gilbert-Elliott or some high-end algorithm loss. But we're just going to do some random loss, and we'll say maybe like 10% packet loss on top of what we're already seeing on the wireless network, right? So the threshold here is usually around 10 to 20% before we turn into the red band. But let's introduce 10 inbound and 10% packet loss outbound. And to show you that we have some packet loss, let's go ahead and start a ping. I've heard these guys have a lot of bandwidth, so we're going to go ping them. We like to ping that a little bit. All right, so we see the ping test. We're getting some relatively low latency, actually, but all the packets are going through, right? We're not dropping any packets here on the ping replies. Looks like just latency between Paul and I. So we're going to hit OK, and we're going to start our packet loss scenario, and we should start to see some drop packets on occasion now coming out. But you still there, Paul? I think I heard you because the door was open, but I didn't hear you coming over the the other piece. Can you maybe like count to 15 for us? Oh yeah, count to 15 for us because I think we're going to hear some of your numbers dropping out.
Okay. 1, 2, 3, 4, 5.
So we're losing some packets there, right? Obviously, this is going to be yeah. Okay, we lost 5 and 6 on you, Paul.
10,
Can you hear us again?
11, 12, 13, 14, 15.
Hey, thank you, Paul. So that's one piece, right? Obviously, if you have poor network conditions, you're going to see an impact then on things like voice quality. The goal here is to be able to surface that again in the UI so that users are aware of where that's coming from. There's one more. Oh, we'll keep that going. One more thing we want to show you, which is how this concept of voice resumption happens when we have a full network loss. Let's assume that my machine drops network connectivity or has an issue of that type of nature. So I'm going to stop my Newt type toolkit. We should see our ping responses resume. But Paul, can I have you start counting to 20? What I'm going to do is I'm going to drop my wireless connection while you're dropping, which will sign me out of Office Communicator and therefore drop the call with Paul as well, right? Paul's packets are guaranteed not to make me if I don't have a network connection. I will then reconnect to the wireless network, and we'll see how long it takes for Paul's voice to resume. So I want to take a vote here. How many of you think that Paul's voice will resume within 30 seconds? Okay, it's a few people are thinking within 30. How long do you think it will take? So let's just watch how long it takes while Paul drops off and Paul comes
Yeah, sure.
back.
1,
all right, Paul. So let's have you start
2,
counting up to 15.
3, 4.
Here's my network cable.
5, 6, 7, 8.
And we lost Paul, right? Network connectivity's down. We will tell you and the client that limited functionality due to server connectivity. We're not able to talk to the server. We're not able to talk to Paul. Obviously, that's a drop call. But let's go ahead and reconnect to wireless.
4, 5, 6.
So Paul's coming back within
7.
a few seconds of that. It looks
8.
very magical, right? It's, all right, Paul. We hear you. You're back. You did a good job. Let's have you come back in and see how that worked. But the resumption is very rapid. I haven't even signed in yet back to my communicator client. You can see that that's still actually trying to sign in. So Paul's presence information isn't there. My status list isn't there. So how does that work? Paul's device is sending those packets or the media stream regardless of the SIP connectivity. So because when I came back on wireless, normal DHCP settings say that I'm going to use the same IP address and then ask if that IP address is allowed to be used again later. I come back online with that IP address, and once that IP address is active, that RTP stream or secure RTP stream is going to hit my device immediately. But at the same time, my device has to go through and re-authenticate. You can see it finally after maybe 20 or 30 seconds, signed back into Communicator and brought up things like presence and everything else. But for the end user experience, a short network drop should literally be just a short network drop. We won't require you to fully reestablish a sign-in and a SIP session to reestablish the voice portion or the voice content of that call. So that ends our quick demo with Mr. Paul. Thank you, Paul. I think you're, are you coming back? Yep, there he's coming back in. It worked well, Paul, even with our network connectivity issues in here on wireless. So we were happy to see that. Let's jump back. So that's a quick demo showing you the concepts of A, why the poorly written USB devices can cause audio quality issues when we're using things like a soft phone, what happens with latency and drop packets, how that's going to impact voice quality, as well as how rapidly we'll resume a voice conversation in the case of a short-term network loss, for example, whether that's WAN-related, client-related, etc. All right. So from this short session, we're trying to keep all these under 60 minutes. You learn the architectural changes for CS14. The main summary is reduced number of server roles. Your simplest deployment is still a standard edition front-end server, but now your enterprise edition servers can have things like the mediation service and the conferencing MCU co-located as well. This obviously facilitates simplified deployment topologies. Your deployment topology now can be as simple as a pool in one location and things like survivable branch appliances in branch office locations. You could have two locations, each with their own pool, if the other location wants to have locally hosted conferences and things of that nature. We talked a little bit about signaling and media. We tried to show you the difference between codecs and what happens when we introduce some packet loss or some jitter into that equation or rerouting of packets. So you can see that the concept of an adaptive codec, or one that can change based on network conditions, will also be able to accommodate that type of WAN drop packets or a little bit of jitter on the network. And then finally, we covered some of the server-side voice features, everything from media bypass to call park to the new PBX-type voice functionality coming in CS14. We didn't cover it in this session. One of the things we cut out, but are in the appendix slides or after the end of the session, is the Enhanced 911. If you have questions on that, there's about 5 or 6 slides in here that cover the E911 scenarios. If you have branch offices or locations in the United States, that's one of the regulatory requirements, is for voice over IP endpoints to publish their location for emergency responders. So in some countries, that's a requirement. So we've added some capabilities around E911, or the ability to send location information to emergency responders when 911 is called. What is the code for emergency here? That's 000? 111? So that would be our equivalent of 111. So with that, whoops, that was back. We'll take some questions. Any questions you guys have on the voice aspects? Question up front, yes. Correct. So the question is, we mentioned the concept of RT audio wideband. The difference between RT audio narrowband and wideband is our sampling period. So our sampling period for narrowband is 8 kilohertz. Our sampling period for wideband is 16 kilohertz, which gives you a wider range of voice that you're discovering, which gives you a better quality of experience for voice. It is similar to the fact that 729 is a little better than 711. RT audio wideband would be our same type of approach, but with an adaptive type codec. Pardon? Oh, okay. Correct. So the question is that's a different codec. So RT audio wideband and narrowband are completely separate from codecs such as G711, G722, G722.1, for example. To do media. So the question's coming is, as the media termination points or the IP PBXs are moving away from G711 towards other codecs such as G722, we would have to ensure that our endpoints would support G722 to continue to do things like media bypass. I'll ask Paul, do you know if G722 is one of the codecs in Office Communicator? We can find this out this afternoon. Okay, yeah, so 722 is already, there's around a half a dozen or 8 codecs that are supported by OC today, 711, Siren. I wasn't sure on 722, but RT audio narrowband, RT audio wideband, et cetera. And so the concept is to put the codec choice into the Office Communicator client and then have that use media bypass to whatever the media termination point is in the org. It can do either or. Because we ship OC worldwide, so it's kind of region-specific as to whether we're using ALAW. So the question was ALAW and MULAW. The OC client supports both due to the worldwide deployment of OC. Question? Yep. Yes. Yeah, yep. So the question is, the content covers the concept of a traditional IPBX, which would be both a registrar and a media endpoint for content coming in or for direction of SIP traffic, etc. What about the world where Cisco is moving to, where you have things like call manager versus media termination points, etc. in the organization? we're working very closely with them to make sure that by release of CS14, we'll have the same type of approaches around both the current iteration. I think they're going to 8.5 shortly. Oh, right. We're aware. It's possible for us, for example, to send our SIP registration to one component of your Cisco infrastructure, would send media to another based on our knowledge in topology builder. So we are, when I show an IP PBX, that could possibly be multiple components or units or even separate IP addresses depending on what the communication stream looks like. So that's kind of an oversimplification, I guess, is I think what the slide shows simplified, but. They have to be on the Office Communicator Interoperability Program as a certified or supported gateway or appliance vendor. So as long as it's there, we can talk to that gateway. I think so the question is, can you share a gateway, right? So if you have another piece of infrastructure or other deployment talking to a specific gateway, can we also talk to the gateway? Yes. It depends. So it's going to depend a little bit on that gateway to determine whether or not it's able to support multiple interface points inside of the organization as well. But we're not going to be limited in sending to the gateway. It's up to that gateway to know whether or not some call extensions go one way or the other, for example. And I think your second point was if you have some existing gateways, right, what's the upgrade path or policy for those? Is that kind of where you're going? We'll cover a little bit of that. The next session is around HA, and we're going to spend about 15 minutes in there on the survivable branch appliances. Many of those can be upgraded from a hybrid gateway that the vendors are shipping today. So if you have an existing hybrid gateway with 2007 R2, it's very likely that your gateway vendor is providing an upgrade path to make that gateway a survivable branch appliance in CS14. So the question is, I heard a rumor that Cisco phones could be used as endpoint devices. Paul? Yeah. So it's kind of yes, right? Which is, we can give you a device that they can register to that'll talk to OCS, but we're not having the device yet register directly into your front-end server pool. I think was that kind of where you're going? Could that device register directly? Yep. Same story as R2. Let's see, I saw something. Yes? Yep. Yeah, so question is, we showed how you could do cross on-premise cloud with CS14 on-premise and Exchange UM in the cloud. Question is, how much of your CS14 infrastructure can be ported? And what we're finding is that as you start to put part of your CS14 infrastructure into a cloud and have it make and receive phone calls, that turns that turns anyone who's running that service into a telecommunications provider, which falls under a separate set of regulations than a traditional data center type approach. We are putting pieces of OCS 2007 R2. Now you can get IAM and presence, for example, in the cloud, and there's discussions underway around how we're going to do CS14 and voice type functionality from a cloud or hosted type model. Primarily those discussions are around the legal constraints right now around providing voice as a service, which typically will classify you as a telecommunications provider. But for example, what about a telecommunications provider offering the service? We're seeing that already happening with R2 and growing with the simplification of the deployment process for CS14. Any other? There was something over here. I thought I saw a hand go up on the side. All right. Well, thank you all for coming out. The demos worked a little better this time. Sorry about that setup and deployment one again. If we have time at the end of the last one, I'll show you the certificate wizard. But thank you very much. Appreciate your time.